Hello students, today we are going to study GIS and GPS. GIS is known as Geographic Information System. A geographic information system is a computer system for capturing, storing, checking and displaying data related to position on Earth's surface. It means that if we want to find the position of any point on the Earth's surface, then we have to use the GIS system. Now the next one is GPS, that is Global Positioning System. GPS is a satellite navigation system used to determine the ground position of an object. Today, GPS receivers are included in many commercial products such as automobiles, smartphones, exercise watches, and GIS devices. Now, the next point is very important, that is, the GPS system includes 24 satellites. That will be the maximum number of satellites included in the GPS system, deployed in space about 12,000 miles, that is 19,300 kilometers above the Earth's surface. They orbit the Earth once every 12 hours at an extremely fast pace of roughly 7,000 miles per hour. The satellites are evenly spread out so that four satellites are accessible via direct line of sight from anywhere on the globe. Now, each GPS satellite broadcasts a message that includes the satellite's current position, orbit, and the exact time. That is the three major parameters. Now, a GPS receiver combines the broadcast from multiple satellites to calculate its exact position using a process called triangulation. Now, three satellites are required in order to determine a receiver's location. Now, this point is also very important from the GATE point of view, because GATE had asked a question from this 2 years before. Three satellites are required in order to determine a receiver's location, though a connection to four satellites is ideal since it provides clock deviation from satellite times. Hence, minimum four satellites are required for a GPS to determine the position precisely. That is, three for position coordinate, that is x, y, and z coordinate, and one is for time coordinate. Now the next topic is the remote sensing. Now what do you mean by remote sensing? Remote sensing is the acquisition of information about an object or phenomena without making physical contact with the object, and thus in contrast to on-site observation, especially the earth. It means that if we want to determine the information about any particular object without coming in physical contact with that object, then we have to use the remote sensing system. Now, remote sensing is used in numerous fields including geography, land surveying, and most earth science disciplines. Example: hydrology, ecology, meteorology, oceanography, glaciology, geology, etc. It also has military, intelligence, commercial, economic planning applications. Now, in remote sensing system, we have two types of system, that is active remote sensing system and passive remote sensing system. Now, we will see one by one each and every type of remote sensing system in detail, starting with the active remote sensing system. Now, active sensors have its own source of light or illumination. It means that in active remote sensing system, they will use their own source of light. They will not depend upon the sun's light. In particular, it actively sends a pulse and measures the backscatter reflected back to the sensor. Active remote sensing systems are not dependent on the sun's electromagnetic ray. We had already discussed it, or the thermal properties of the earth. Now, active remote sensors create their own electromagnetic energy that is transmitted from the sensor towards the terrain, interacts with the terrain, producing a backscatter of energy like this, okay, and is recorded by the remote sensors receiver. The most widely used active remote sensing systems include radar, sonar, etc. Now, radar is known as radio detection and ranging, and sonar is known as sound navigation and ranging. Okay, now we can move to the next remote sensing system, that is passive remote sensing system. Now, remote sensing system which measures energy that is naturally available are called passive sensors. It means that in passive remote sensing system, suns are used as source of electromagnetic rays, and in active remote sensing systems, satellites are used as a source of EMR. Now, passive sensors can only be used to detect energy when the naturally occurring energy is available. For all reflected energy, this can only takes place during the time when the sun is illuminating the earth. There is no reflected energy available from the sun at night. Energy that is naturally emitted, such as thermal infrared, can be detected day or night as long as the amount of energy is large enough to be recorded by the sensors. Now, the most widely used passive remote sensing systems includes photography, infrared, charge coupled devices, radiometers. Now, we can move to the next, that is enhanced thematic mapper sensors remote sensing satellite, that is Landsat 7. Now, this sensor on board the Landsat 7 satellite has acquired images of the earth, which is shown like this, continuously since July 1999 with a 16-day repeat cycle till now, and it have generally 8 number of spectral bands. Band 1 will be blue, band 2 is green, band 3 is red, band 4 is near infrared, that is NIR, band 5, that is short wave infrared, that is SWIR1, band 6 thermal, band 7 short wave infrared, SWIR2, and the band 8 will be panchromatic. Now, these are the spectral bands of Landsat 7. That is all about the GIS and GPS. Thank you very much, students.